The surface of the Earth is broken up into big blocks called plates, and they're moving constantly a little bit at a time. This slow movement builds up pressure, and that pressure can cause earthquakes. When there's an earthquake, there's motion along a fault, and you have ground shaking, which can be quite scary. And that can cause damage to buildings and pipes that bring your water and other utilities such as electricity, and that can cause fires. As soon as there's an earthquake, our team gets together. The first place that we go to is the U.S. Geological Survey, which provides us the information about where the earthquake has occurred and how large it is. And then we get information from GPS, which is the Global Positioning System. This is the same sort of technology that you use in your telephone to locate yourself. We can use this to precisely locate where that piece of Earth is and show how it has moved both up and down and to the side. Then we develop an information map called a tilt map, which has colors that show where the biggest motion has occurred with arrows that show the direction of this motion. So the tilt map is useful because it shows where the ground might be moved up and structures might have been damaged and the water lines might be flowing backwards, and also if the utility lines have been broken underground. And we get that out to the mayors and the police department, fire department, so that they can make their decisions. It can be very chaotic after an earthquake. Sometimes you don't have power, so you can't get to your computers, you can't get the information. This happened in Japan after the big earthquake, and so the Japanese went out to international partners to try to get help because they themselves were not able to respond. And we were able to provide information that helped them out a lot in a huge disaster. And I think that when an earthquake occurs here in California, that we'll be able to provide similar information. In order to do this job, you should be able to do math and science. I was not that great at math, but I persevered and worked really hard at it. When I was in high school, I actually thought that I wanted to be a journalist. I was a freshman in college, and I was in the dorm, and the Northridge earthquake happened. And I grew up in a place where there were no earthquakes, and this was my first earthquake, and I thought this was the coolest thing ever. And I got a degree in journalism as well as a degree in geology, and the geology won out. But having the journalism degree has been very helpful because what people may not know about science is that you have to write proposals in order to get your research paid for. We send in grants to the government, and they decide whether or not they're going to pay for our research. While I think that earthquakes are devastating and can cause a lot of damage, I could very, very well say that I love earthquakes, and it's the most exciting thing in the world to me.